All right, stats, especially for my kids currently in quarantine. Here's a homework help video for the Chapter 10 homework set, which I will email you when your due date is. In fact, this is the Chapter 10 homework set, and I have just changed some numbers a little bit. So taking a look at this, extra GPA. If GPA is calculated on the 4, 3, 2, 1, 0 scale, find the average GPA earned for this Intro to Stats class. So that's the proportion of students. This is 0.25, 38, 16, 10, and 11. The proportion of students that earn their grade. So it's an expected values, the GPA here. So they get 4 points for getting an A, and the proportion of students getting an A is 0.25, plus 3 points for a B. The proportion of students getting a 0.38 that's the proportion getting a B, that is 0.38. You get 2 points for a C, and that's the proportion. The probability of a student getting a C, plus 1 point for a D, that's the probability, plus 0 points. Yes, you got to show this for getting an F. That is the proportion of students, or the probability that I'm getting an F. So then multiply and add them up, and 2.56 is the GPA for that class. Number 2, you toss a coin 3 consecutive times. 2 to the 3rd is 8. For yours, it's going to be more. There are 8 different unique events here. We start with the 3 heads, 2 heads and a tail. Another 2 heads and a tail, but look at that ordering. There's another way to get 2 heads and a tail if you get a tail and 2 heads. Let's look at all the ways you can get 2 tails. Heads, tails, tails. A tails, heads, tails. And a tails, tails, heads. And you can get 3 tails. All right, so what is the probability of exactly 2 heads or 2 tails? Look above here. So that's 2 heads, that's 2 heads, that's 2 heads. This is 2 tails, 2 tails, 2 tails. So of the 8 events, 3 are exactly 2 heads, 3 are exactly 2 tails. 6 out of 8, 3/4, 0.750. What's the probability you roll exactly 1 head or 2, or 1 tail, sorry. Well, 1 head would be that one. It's going to have the same answers before that one, or that one. And 1 tail would be that one, that one, that one. 3 plus 3, this is how you explain your reasoning. You show me all that good arithmetic. Again, you're writing me a probability statement right there. Probability 1 head or 1 tail. And then that is the probability. All this work you see here, that's what I expect on your homework sets. Let's take a look at this next one. You will roll 2 dice at the same time and calculate the sum of the rolls here in this example. So x equals the sum. Make sure to define it. State the sample space of this event. 1 through 6, 1 through 6, first roll, second roll. Here, it's the sum. On yours, it might be different. Those are the 36 different sums. 36 different events, that is. What's the probability of getting a sum of 10? Probability x is 10. There are 3 10s in 36. That's 1/12, which is 0.083. What's the probability of getting a 10 or greater? So you can show it by doing those 3 plus those 2 plus that 1. In fact, that's what you should definitely do. Probability x is greater than or equal to 10. What's the probability of getting a sum of 5 or greater? So 5 or greater, it is these on down this way, or everything but this 1 and 2 and that 3. And those 3. So you can just do 36 minus 6. There are 30 sums that are 5 or greater. That's 5 out of 6. That's 0.83 repeating. Then find the expected value of the sum of the 2 rows. First off, there's 36 different sums. There is 1, 2. There's 2 3s. There's 3 4s. There's 4 5s, 5 6s, 6 7s, 5 8s. 4 9s, 3 10s, 2 11s, 1 12. And that is exactly what I wrote here. Expected value 7. You find the sum there up top divided by 36. All right, you are at the free throw line and currently shooting 72% this season. You're shooting 2 free throws, so X is a made free throw. What's the probability that you make them both? Probability X is 2 is 0.72 times 0.72. Round them to 3 decimals. What's the probability you make exactly 1 free throw? You can either, probability X is 1, you can make it, miss it, or you can miss it, make it. Depending on how you round, you get 403 or 404. Okay, add both those up. There's a probability that you make at least 1. So the probability that X is greater than or equal to 1, usually we want to do 1 minus the probability that X is 0. So the probability of failing twice, 1 minus that, will give you that. Or the probability X is greater than or equal to 1, in this case, is the probability you make 1 and the probability you make 2. And we already have those probabilities from A and B, so you can just add them up as well. Again, depending on rounding, you get 922 or 921. Now you're going to shoot 3 straight. What's the probability you make all 3? 0.72 to the third. What's the probability you make at least 2 of them? So the probability that X is greater than or equal to 2 is the probability you make 2 plus the probability you make 3. The probability you make 2 is this: make it, miss it, make it, miss it, make it, miss it, make it, make it. So it's 3 of the 0.72 squared times 0.28. Yeah, depending on how you round. Well, it doesn't matter how you round, you're going to get 435. And the probability you make 3, you did that in part D, so just add them up, 808. Then what's the probability you make at least 1? Probability you make at least 1 is 1 minus the probability you make none. 1 minus 0.28 to the third. There we go. All right, then the very last one here. Say Mr. Yak has 4 races on his calendar in a given month. Currently, I have that for December. He has a 40% chance of winning the first race. That's probably not true now. 32% chance of winning the second race, also inaccurate. 60% chance of winning the third race, probably not. And a 20% chance of winning the fourth race. Okay, so maybe when there's a lot more races available and these were all small, this could have been true. What's the probability that he wins none of them? So X is a 1 race. Probability X is 0, means 4 straight not winning. So it's the complement 4 straight times. 40% chance of winning, 60% chance of losing. 32% chance of winning, 68% chance of losing. 60% chance of winning that race, 40% chance I don't. 20% chance of winning the race, 80% I don't. Multiply them all together. It's probability of 0 wins. What's probability? Win all 4. So take those percents, turn them into probabilities you were given in the original. Probability of winning all 4 is that, 0.015. Show that work. So then what's the probability I win at least 1? It's 1 minus the probability of, that's not right. 1 minus the probability of 0. Okay, and the probability of 0 was 131, so it's 869. 869. Then what's the probability of winning exactly one of these? I don't even change these numbers anyway either, so lucky you. What's the probability of winning exactly 1? Well, winning exactly 1 could be done in the 4 different scenarios. Win followed by 3 losses. Loss, win, loss, 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 win, loss, 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 win. Or a not win, because, again, you finish third, get a nice award. That ain't losing. All right. So, and those are all the probabilities. Again, if you don't win, it's the complement of your probability of winning. Okay, so all those L probabilities are the complement of winning that race. And then you're just going to add them all up. All right, that is your homework set, Chapter 10. This is Yak Math Videos signing out.